Hello, Mr. Lee. This is my presentation, my video essay on.
So hello everyone, so this is my curved graph. Okay, it's just a random function, and you can see this in point A and f of A. You can also see it on the graph, A and f of A. And I drew a tangent line at a point, which is this point A. And so I'm gonna be explaining how you can use limits to determine the IRC formula, like the slope, because instantaneous rate of change. As you can see, this tangent line, its main concept corresponds to instantaneous rate of change, which is what the first question asks us. It's like, what concept does the slope of the tangent correspond to? And the concept it corresponds to is instantaneous rate of change. Okay, so now I'm going to show you an actual function, and I'm going to try to use that to explain what I'm trying to say. So this is my actual function, and I'm going to show you 2 points. Okay, so where are my 2 points? Okay, these 2 points. So normally my actual function, it's f of x equals x squared minus 6 when x is equals to 1. So I'm going to draw a secant line, and I'm going to actually, first of all, I'm going to explain how I got these 2 points. This first point is from when x is equals to 1, and this is the first point. You can see first point. And then for my second point, I used this formula to get my second point. So this A is like my first point, and this is my second point. So this is like x1, and this is like x2. And if you remember clearly, when I showed you the first formula from the first one, this is what limits comes into place. So I'm going to explain how this h approaching 0, where it comes from, and like the meaning. So for my second point, when I used this formula, I added 0.5 to my second point. That was how I was able to get this. So I got 1.5, 0.5 plus 1, that's how I got 1.5. Then I put the 1.5 in this formula, and I got minus 3.75 as my y value. So now I'm going to draw a secant line to this. Okay, as you can see, this is when x equals to 1, and this is my 1.5. Wow, sorry, I don't have a ruler, so I'm just going to use this pencil. So okay, so this is my secant line, and secant line is like in between 2 points, and it goes right through the graph. Maybe you can't see it clearly, but there's like a space in between on this side here. And just in case you were wondering, this 1.5, there's a part of this question that says, what does interval correspond to? So this interval corresponds to my preceding interval. Okay, so this is my preceding interval. So I use this, and this is my formula for my preceding. This, there is the then, as you can see. Okay, and so these are my 2 points, first points and my second points, and I'm going to explain how to get the slope of the secant line and how to get the equation of the slope of the secant line. Okay, so first of all, as you can see, this is my equation, changing y, we're changing x, which is rise over 1, which is saying minus y2 minus y1 over x2 minus x1. This is my first point, this is my second point. And after I did everything, this is the slope of my secant. Okay, so I'm going to show you how to get the slope of the equation of the slope of the secant line. And so this is my formula for the equation slope of the secant line. So this m is the slope, which is this 2.5, which I got. So I put the 2.5 here. And for my x1 and my y1, I can pick any of these points. So I picked my first points 1 and minus 5. So I put 1, I put minus 5. I did this, and my equation was 2.5 y equals 2.5x minus 7. That is the equation of the slope of the secant. Okay, so the next question tells us, what can we do to make this point here approach the tangent? What can we do to make the secant approach the tangent? Okay, so if I was to draw a tangent line now outside here right now, okay, so this is my tangent line. Okay, this should be more clear. What can I do to make this line bend towards this direction to be close to the secant? Like I said, I told you I was going to explain how limits works in this situation. And so look at this. The closer h is to 0, the closer this secant line is going to approach the tangent. I'm sure you understand. Like okay, let's see if I can explain furthermore. Let me show you my formula. Okay, no, the formula is already here. So, for example, like what I did here, I put this point, this other point, and I told you my 1.5 came from me making this h in this formula 0.5. So if I was to make this smaller, let's say 0.1, my value, my point here is going to move closer, and it's going to be, let's say I use 0.1, it's going to be closer, it's going to be like here. And then if I should draw a secant line, it's going to bend, and it's going to be closer to my tangent than this one. Okay, so the h was considered in this one, and the smaller the h, the closer the secant line gets to the tangent line when you're trying to get an interval. Okay, so another point that should be considered is the preceding value. If you remember, the first time we did this, we used this equation, which was a bracket this plus h, and so this would give us the following value. And so if we want to get the slope of this tangent, we would need the following, we would also need the preceding too. So for us to get the preceding, we have to use this interval, which is a minus, exact the reverse. And so this is the formula for the preceding. Oh yeah, I think I also made a mistake before when I was showing you the formula for my following. I showed you the preceding instead of the following. So this is the formula for following, and this is the formula for the preceding. So you need the following interval and you need the preceding interval. So if you want to get the slope, you would look at this and you look at this value. So when I use my formula for my preceding, I use my formula for my following, these are the values I get. So if I add these two values and I divide by 2, I would get a value, and that value is going to be my tangent for the line. Or if you don't want to do that, you can also do the centered value, which is 2 from this equation here, and this is the formula for the centered value: f a plus h minus f a minus h divided by 2h, and you get 2. And if you notice, 2 is also in between my following and my preceding. Okay, and so that's how you get the slope of the tangent. So I'm just going to put that here. And so this is the other point you're going to consider. If you do the interval values, which is this one, and you get minus, this is where your other point would be. And if I was to draw a secant from there, it would be here, from this preceding point to my following point. So draw this. Got it. And the point in between will give me the slope of the secant. Okay, so now I'm going to move on to the last question, which talks about two-sided limits and the left and right limits. Okay, so the first question is x1 must be true about the about the left and the right limits for a two-sided limit to exist. And so, for example, let's say this is our graph. So if you look at this graph is a continuous graph. Let's say we pick a point here where x is 1, pick another point, I don't know, let's say minus 3. Then you decide to trace a point here. Okay, so, and you're trying to get to see if a two-sided limit is present or not. So for a two-sided limit to exist, the right side must be equal to the left side. So the left side and the right side must have the same value, and the graph must be a continuous graph. And also, okay, so I'm also going to give you another one too. So two-sided limits also affect the way the tangent looks in the graph. Okay, so let's say this is my point here, and I have to draw a tangent. If this graph was not a continuous graph, the tangent should not exist, as per, like, if this was a graph that had a hole, let's say this is like this, and this graph stops here, like this is my hole, and it is not complete. This tangent would not exist. So if a two-sided limit is not present, then a tangent cannot be present. And for a two-sided limit to be present, a graph has to be continuous. So you can get the left side, the right side, and then two-sided limits. Thank you very much, and this is the end of our presentation.